I have the pleasure of introducing Mr. John Preston, a National Trench Safety Senior Safety Trainer. John has over 25 years of experience in the excavation safety industry. He's held a position as Director of Training and a Director of Safety and is currently serving as a Senior Safety Trainer for National Trench Safety. John has developed and delivered an array of training programs, including excavation safety, competent person, and the Train the Trainer for excavation safety courses. John is also an OSHA outreach instructor and teaching the OSHA 3015 course, as well as the OSHA 10 and OSHA 30 hour courses. He holds a master's degree in training and development. And we're very pleased to have Mr. Preston as a part of the National Trench Safety team. So, Mr. John, with that, I will turn it over to you, sir.
Thank you, Jay. Welcome, everyone. Good afternoon. This is a very important safety topic, and what I'm hoping is that some of the things you learned today would not only be applicable as you deal with safety issues around excavations, but also provide you some ideas for safety talks that you can give whenever you have that opportunity. So first, let's begin by looking at the anatomy of an excavation. We start with the toe, which is the bottom of the excavation, and then the top is the lip, and then of course we have the face or the sides. And it's important to understand this because when we start talking about the adjacent area, we're looking at the area out from the lip that is equivalent to the depth. So for example, if we're 8 feet deep, we're talking about the distance 8 feet out from the lip. Now, this adjacent area is important, and as Jay pointed out, it's a sacred area. We really have to respect this area, and we also want to think about the area below ground as well. There's two situations where we say that the adjacent area is significant. One has to do with protective systems, and the other has to do with structures. It all begins with gravitational forces, because the gravity pushing down on the soil is going to translate to cave-in forces when we dig an excavation. That's why it's important to understand that all vertical soil walls will eventually collapse. And that's because the gravitational forces are greater than the strength of the soil. So shoring systems are designed to support the sides of the excavation and push against those cave-in forces to prevent a cave-in. As long as the shoring systems are positioned correctly and pressurized correctly, they are adequate to prevent a cave-in. However, any additional forces that we have pushing down, we call those additional forces surcharge loads. Any additional forces pushing down are going to add to those lateral cave-in forces that we talked about. And that's why we have to put a limit on those surcharge loads, because too much of a surcharge load could overwhelm the strength of a shoring system. So what are those load limits? How much weight can we put in the adjacent area and still be okay? We're going to take an example from Appendix C of Subpart P, timber shoring. And if you're not familiar with Appendix C, it has some tables and charts that will specify both the size and the spacing of the wood shoring members. It's also in Appendix C that we get the definition of the adjacent area. And let me just take a moment here and say, this is one reason I think why some people aren't familiar with the adjacent area, is because it's only defined one place in the OSHA standard, and that is in Appendix C. So Appendix C gives us the size and spacing of the wood shoring members. It defines the adjacent area, and then it also gives us the load limits that are allowed within the adjacent area. A timber shoring system has three components. We have the uprights. These are planks or boards that are going to be pushing against the face or side of the trench. And then we have the horizontal structural members called wales, and then pushing against those wales are going to be the structural cross braces. So uprights, wales, and cross braces make up our timber shoring system that we see in Appendix C. What's important is the size and spacing of each of these members. The deeper the trench and the worse the soil is, that means these structural members have to be larger and they have to be spaced closer together for strength. In Appendix C, in the adjacent area, we are limited to a 20,000 pound surcharge from equipment, or we're limited, or I should say, and we're limited to a maximum of a 2-foot high spoil pile within the adjacent area. Again, it's because these surcharge loads pushing down, translating into lateral forces, could overwhelm the structural shoring system. The size and spacing of these shoring members are not going to be considered adequate if the surcharge load is too great. Now, every protective system that we use has a surcharge load limit, and that's going to be found in manufacturer's tabulated data, or it could be obtained by contacting the manufacturer of the protective system to find out just exactly what the load limits are in the adjacent area. It's common to see a trench shield or a shoring system to have a load limit of 36,000 pound surcharge load, and limits of a spoil pile to about 3 feet. While we're talking about this spoil pile, let me point out that the spoil pile cannot be any closer than 2 feet from the lip. Now, that is not because of surcharge loading. That is for roll-off protection. We don't want any soil to end up coming down into the excavation, so we are required to keep it back. OSHA's limit is 2 feet. Some companies have 3 or 4 feet distance requirements. Let's move our attention to the adjacent area structures and what those hazards look like. First of all, in the general requirements in Subpart P, 1926-651, the very first one, paragraph A, talks about surface encumbrances. It specifically says that all surface encumbrances must be supported or removed to safeguard employees. Now, in the Federal Register, we get some clarification on what these surface encumbrances are. They specifically give examples of trees or boulders that might become unstable and might collapse into the excavation due to our trenching. And so we have to support or remove any surface encumbrance like this. A utility pole is another example of a surface encumbrance. And the rule of thumb is if the utility pole is positioned inside the adjacent area, then we're going to have to support it. Of course, outside of the adjacent area, we don't have to worry. But this is a common question. Do I need to worry about this utility pole or this light pole? And the answer is, if it's within the adjacent area, absolutely. If it's outside of the adjacent area, then it's not so much of a problem. Continuing in the general requirements in 651, paragraph I says that excavating below the level of the base or footing of a foundation or retaining wall could be a hazard to employees, and it's not going to be permitted unless a support system is provided. Now, by support system, they're specifically referring to shoring. An example of such a structure might be a wall. We have a picture here of someone working in a trench where there is a wall in the adjacent area, And in this particular situation, they did not have any shoring in the trench. And when they were asked about this, they didn't really grasp the seriousness of the situation, and they did not put shoring in. And this is what happened on another day. This wall collapsed and caved, predictably collapsed and came in. And fortunately, no one was in the trench when it collapsed. In the requirements in 651, paragraph I, it says, where the stability of adjoining buildings, walls, or other structures is endangered by excavation operations, support systems such as shoring, bracing, or underpinning shall be provided to ensure the stability of such structures for the protection of employees. The same paragraph, it continues and says, sidewalks, pavements, and appurtenant structure shall not be undermined unless a support system or another method of protection is provided to protect employees from the possible collapse of such structures. I'm reminded of a fatality that happened where a worker was in a 3-foot deep trench. A section of sidewalk in the adjacent area came loose, fell into the 3-foot deep trench and killed a worker. It's important for the competent person to recognize any structures that could be in the adjacent area and make sure that there is a shoring system to support it, regardless of the depth of the trench. This OSHA fatality story was taken from the OSHA website. At 2:59 p.m. on December 17th, 2019, employees number 1 and number 2, employed by a construction company, were working inside a 32-inch deep trench and using shovels to dig under a concrete foundation slab/wall at a residential structure. Let's go back and look at that. That's a 32-inch deep trench. That's 2.5 feet. The concrete slab, which measured 8-inch thick by 12 feet long by 24 feet wide, became dislodged from the surrounding soil and collapsed onto the 2 employees. Employee number 1 was pinned between the concrete slab and the trench's opposite dirt wall. Employee number 2 was pinned face down between the concrete slab and the ground. Emergency services arrived, determined that employee number 2 had no pulse, and resuscitated him. Both the employees were transported to the hospital and admitted. Employee number 1 was treated for multiple fractured ribs and other injuries. Employee number 2 died at the hospital from crushing injuries on December 22nd. That would be 5 days later. So in this shallow trench, approximately 2 feet 8 inches deep, a section of this slab came out, and there was unfortunate consequences. I was very curious about this event, and I did some further research, and I found a newspaper report that gave a little bit more insight into this accident. 2 construction workers were rushed to the hospital Tuesday afternoon after a shallow trench collapsed and trapped them in under a slab of concrete. The contractor in charge of the work site, where the men were in the process of building a 2-story addition to a home in the 5300 block of North Tyrone Avenue, said it happened in a split second. It was a very poor built foundation, said one person. Whoever built that a while back didn't put any rebar on it. So what happened is a chunk of concrete just kind of fell on top of the guys. Now, this to me is a reminder of how, regardless of how shallow a trench is, if there's a structure in the adjacent area, it needs to be secured. It needs to be supported, because we have no guarantees that those structures will stay where we want them to stay. We're going to have to ensure that they are held in place while workers are in the trench. And this is just a really sad story and a reminder of the importance of these structures. One of the types of adjacent structures that often is forgotten, which is something as simple as a sign base. Anytime that there is a sign, there has to be there's usually some structure underneath that sign supporting it. And these sign bases can be quite deep. If the sign base is outside of the adjacent area, then it's not as big of a problem. But anytime we have any structure such as a sign base within the adjacent area, we really do need to pay close attention and make sure that as we dig, that we are supporting that structure. Now, another scenario that we often encounter is the presence of a building near our excavation. If the building is within the adjacent area, then we need to pay attention and we need to support that structure. Now, it might be that the building is large enough, we might need to get an engineer involved. For a lot of small buildings, simple over-the-counter shoring is sufficient. But for any large building, it's very important to make sure that we have the assurances that we're going to not only protect that structure and protect that asset, but we want to make sure that any employees in that excavation are going to be safe. And an engineer can tell us what we need to do. Parallel utilities also present problems if they are in the adjacent area. You might have seen the cave-in story from Boston, where there was an existing water line that broke when the dirt side of the trench caved in and trapped 2 employees, and the water quickly filled that trench. It resulted in 2 drownings. Anytime that there is an existing utility in the adjacent area, we need to support that so that it doesn't move. The consequences of ignoring these kind of things are serious. In the general requirements in paragraph K, it talks about doing inspections. The competent person has to do daily inspections. And one of the areas it says to inspect is the adjacent area. It says we need to inspect the adjacent areas and protective systems. It shall be made by a competent person. The competent person is looking for evidence of a situation that could result in possible cave-ins, indications of failure of protective systems, hazardous atmospheres, or other hazardous conditions. An inspection shall be conducted by the competent person prior to the start of work and as needed throughout the shift. Inspection shall also be made after every rainstorm or other hazard increasing occurrence. During these inspections, the competent person should examine the adjacent area and make sure that, in addition to everything listed in paragraph K, that all of the items, structures, parallel utilities, whatever's in that adjacent area is taken care of. I want to thank you for joining us today for our seminar. I'll turn the meeting back over to our moderator.
Thank you, John. Does anyone have any questions for John today? You can put them in the Q&A and I'll read them off to John if you have a question. So far,
While we're getting some questions, I have one more point I'd like to bring up that sometimes is a question that people have, and that is whenever someone is sloping or benching, a lot of times they wonder if the adjacent area still comes into play. And the answer is in subpart P in Appendix B, OSHA does make reference to surcharge loads when sloping or benching. And the specific requirement is that the competent person has to evaluate those surcharge loads and make sure that the surcharge loads are back away from the edge of the excavation, and the slope of the excavation may have to be reduced in order to accommodate the surcharge load. So the attention that's given in subpart P is very generic in nature, but it does address the point that surcharge loads can contribute to problems even when sloping and benching.
John, I'm looking, okay. So Mike Jones's question, when it comes to surcharge loading and utilizing hydraulic shoring, would you agree the tabulated data should give you the limits of what the shoring system is rated for?
Yes, the tabulated data should provide that, but if it's not there, the manufacturer should be able to provide it as well. Excellent point.
Any other questions? Someone, let's see. No, no one's raised their hand. There are no other questions for John or Jay? Okay, guys. Well, I'll tell you what, we are recording that. John, if you could take it back to the original screen, that would be great. And I'm going to send the link out once we finish wrapping up here and I download it. So we'll be able to send this out for everyone to re-listen to again that was not able to get on it today, thanks to the incompetence of the person that set it up.
I would like to just say thank you for inviting us to your webinar today. Thank you very much. We appreciate that. And maybe if there's questions in the future, you can always reach out.
We have
But
another
anyway.
question for you, John.
Okay.
I don't, what is the max allowable distance between a trench wall and the outside of a trench box?
Okay, that's a really good question. And the answer is that OSHA does not allow a trench box to have any lateral shift. It's not allowed to move sideways. And so the industry, so OSHA just says no lateral shift. The industry standard has evolved to where we translate that to mean a no gap more than 4 to 6 inches on each side of the wall. Now, some manufacturers might say no gap is allowed and you have to backfill any gaps. But many manufacturers say a 4 to 6 inch gap on each side and no more than a foot overall, wider than the width of the trench shield. I hope that makes sense. OSHA just in a letter of interpretation, they didn't really want to give any specifics on that except to say prevent lateral shift. That is a very big and a huge important safety concept when using trench shields. So fill the voids if it's going to be wider than 6 inches on each side, on either side.
Any other questions for men? Oh, we have another question now. Great. All right. When working in soil with expansive properties, is it important to have a minimal gap between the trench and the trench box?
I'm not sure if I understand the question. Are they saying that should there be at least a small gap because of the soil expanding?
So you can look at the question also, but it says when working in soil with expansive properties, it is important to have a minimal gap between the trench and the trench box. Is it? And Mike says that was a statement for others. Sorry, Mike. Anyway,
Well, just to make sure there's no confusion, the principle that a shoring system, by definition, the principle is that the shoring system prevents soil movement. Trench shields are different from shoring systems. They don't prevent soil movement. What they do is protect workers so the soil can fall against the shield and the shield takes that load. And so the worker inside the shield is protected from the falling soil. So that is why we want to make sure that the gap on this between the face of the trench and the side of the trench box is minimized so that that shield does not move sideways when the soil caves in and hits it. So that's a very important concept. I want to make sure everybody understands that we need to make sure the shield does not move laterally.
you see the next question, would there be an LOI for excavations that are partially sloped along the running line of the excavation in regards to lateral shift for trench boxes?
I don't know the answer. I don't know the answer to that. The LOI is referring to a letter of interpretation, and someone could always present that to OSHA and ask that question. I don't think there is.
I don't, let's see here. We have any more? Okay. So Lorenzo says a common work practice that we would employ would be to kick off the trench box at the top to prevent lateral shifting. I don't know if you want to comment back on that or not. Or
As long as the trench box is prevented from lateral shift, I really can't comment.
all right. And then you have another question from Mike. When stacking trench boxes, how many pockets of the 4 are required to be pinned? Is it 3?
I have never heard that question raised before. That's an interesting question. And what we are instructed to do is to follow the manufacturer's recommendations, specifications, and limitations with respect to our manufactured systems. I would be surprised if there is a manufacturer out there that does not require all pins to be in place. When trench shields are stacked, they must be pinned together. And I believe that every manufacturer that I've seen requires that all of the pins are in place. And that would come from the manufacturer. OSHA does not address that.
Hey, John, can you hear me?
I can.
John, what's the maximum distance or height a trench box can be off the bottom of a trench?
We are allowed to hold the box 2 feet off the bottom. That's the maximum we're allowed to go 2 feet off the bottom. But there are some limitations. One, the trench shield must be rated for the entire depth of the trench. That would include the 2 feet that we're trying to dig down below the box. And that limitation would be found in the manufacturer's tabulated data. The second limitation has to do with the soil. One of the concerns, and actually it's actually found in the definition of a cave-in, one of the concerns is that soil could come underneath a trench shield and entrap someone. That's why no one's allowed in a trench shield when it's being lifted, because the soil could come underneath the trench shield and entrap someone. So the two requirements to dig up to 2 feet below a trench shield are the shield is rated for that entire depth, and secondly, that the soil will stand and is not going to come underneath that trench shield.
Thank you.
Good question. By the way, a question that I think someone might have about the adjacent area would be, does the adjacent area extend out the same distance in all soil types? For example, today we discussed the 1-to-1 ratio, where the adjacent area would extend out from the lip out equivalent to the depth of the trench. That 1-to-1 ratio is for the most common, normal, average soils. If someone is working in very poor soil conditions, the adjacent area would logically extend out further. So just so everybody knows, what we were talking about today is just average conditions.
Amanda, do we have any more questions in the queue? Amanda, are you still there? We lose you.
Yes, I am here.
Okay.
There are no more questions in the queue. Would you all like to, says Mike Jones, for some reason I can't get you all to hear me. Jay, would you like to say anything to close out, or Ray?
I'd just like to.
Go ahead,
Oh, there
Ray.
you are. I was just going to say I'd like to thank AGC for hosting this today, and if there are any other questions, I'm here locally with National Trench Safety, and I can reach out to John and get any other answers that we might need.
Mike Jones has raised his hand. Okay, Mike, you should be able to, if not, let me put 10 days. You should be able to unmute yourself now. And allow to talk. Okay, go for it, Mike.
Okay, the reason I asked about pinning the boxes, if you had to have 3 or all 4 pinned, is there's sometimes issues when we're putting in deep pipe and we have shallow utilities. So let's say we're using a 24-foot trench box in the bottom. Maybe there's 2 of them stacked up. When we come up to those utilities, we want to maybe remove the top 24-foot box, slide the bottom one under it, and then set maybe 2 12-foot boxes on the top so that the utility's in the middle. So that's why I'm wondering how many of those pockets need to be pinned.
Okay, that's a very good question. And what I would do is I would contact a competent trench safety representative, a field representative, and have them come out and deal with those situations one-on-one. There's so many situations like that where the best advice you're going to get is from a field rep. For example, if you have a good relationship with a National Trench Safety or other equipment dealer representative, have them come out and look at it and talk about that. I don't think, from where I sit right now, I don't think I could give a good, safe answer.
So it looks like, John, that Nathan Jonovich asked, what is the minimum height allowed at the bottom of the trench box in the chat?
So that sounds like we might have answered that when we talked about
Okay.
the 2 foot, you're allowed to dig 2 feet below the trench box.
Okay,
A lot of issues that people see is, and they don't really know how to address it, is let's say you're laying 36-inch pipe. Well, usually per mag standards, you're only allowed to be a certain max allowable width at the top of the pipe. So guys want to run that box up at the top of the pipe zone, so now essentially they're 3 foot, little over 3 foot off the bottom. So that's either something that needs to be engineered, or you need to find another way to do it, but you still only allowed 2 foot off the bottom unless you have engineered.
That's correct.
I mean, I've even been in situations where you're using boxes on the first half of your trench, vertically from the bottom up. And with shallow utilities, you're using hydraulic shores on the top. The big thing is just making sure the rails overlap the outside of the trench box.
anyone else? All right, then, I guess that's it. We'll close it out. Thank you all again. I will get this done as quickly as possible to get the recording out to those that might have missed it. So join us again the next time we have another webinar. Guys, thank you very much, Ray, Jay, John. My apologies for some of the technical difficulties we had today.
Thank you for the invitation.
Sure.
Have a good day, everybody.
Bye.
Thank you very much. Have a good day.
Thank you.